Okay, hello everyone. My name is Maciej Polanczyk. I came here from Poland and I'm a Python developer. Today I would like to talk about mocks and patches in Python. So before we start, how many of you are creating unit tests when you develop? Please raise your hand. Okay, so this topic will be familiar at least to part of you. To everyone, other people, do you develop or you don't develop in Python or anything else?
Do only end-to-end.
End-to-end.
Test.
Okay. Okay. So, yeah, I work for Blocktrade. They paid for my visit, so I will just tell one sentence about Blocktrade. Blocktrade is a marketplace for cryptocurrency. We use a lot of fancy technology. So if you would like to talk about those technologies, we can do it after the presentation. And now, the most important question, why are we here? We are here because I prepared Mojito drinks for you guys. And if you want to get one of those, and they are already here, I can show it to you. Yeah. Okay. So if you want to get them, then you can do it because I will have some questions during the presentation, and for those who will try to answer those questions, I will give one of those nice Mojito drinks. And I have a lot, so please try to get them. It will be very easy. Is this a test? No, this is not a test. Yeah. Okay, so this is a plan for today. For start, I would like to show you an example of a class which we will test. This class will be used just for the purpose of the presentation. Then I will show you a basic test which will be extended during the presentation. And then I will tell you about the mocks, how we can create them, how we can use them, and what are the tricks about them. Finally, I will tell you about the patches in Python. And if you want to get more knowledge, then I can show you during the presentation. Then you can just go to the URL with the documentation and you can read more about the topic. So, yeah, I had a plan, but I see that not so many people are doing the unit test. So maybe I will first tell you about the concept. So when we create the code, we can just put it on the production and say that it works. We can, of course, test it manually before putting it on production and check that it works. And yeah, it works, okay, we put it on the production. But in the end, after doing some changes in the code, something might be broken, or the code might be so big that we can just check only one thing that we changed currently, and we are just not able to check the rest of the things. So in the end, we will always have some kind of failure. So many years ago, people decided that it will be great if we could somehow test our code before going for production and to not do it manually, at least at the beginning. So what developers can do, they can create tests for their own code. And the presentation is mostly about the test, but not about the idea of creating the test. I just assume that we already know what is the testing when we develop our code, and I just wanted to talk about mocks and patches which allows us to create better tests. Because when we test, sometimes we need to not use the real objects in our tests, but some kind of objects that will pretend the real object. And this is the topic of the presentation. So let's go to the plan which I prepared for you. If you will have any questions, please answer during the presentation. Okay, so let's say that a client came to us, to our company, to us as one developer, doesn't matter. And the client said that he has a lot of money, as you can see, and he would like to implement his idea. So why not? Let's take the money and let's do what he asked us for. So we take our ninja developers, and actually those guys really exist. I work with them, they are really good, and this picture with the text is created by the reason. And after a few weeks, let's say that those ninja developers created a lot of code, and one of the codes of the classes look like this. So we have a message sender class. So based on the name, we can think that probably it sends a message somewhere. And as you can see, yes, there is a send method in here. This method takes a message as a parameter, And yes, this class could be improved, of course, but for the presentation, the structure of the class is like this. So the method send, as you can see, it just sends in here the message, the content of the message, to some server using the request library from Python. And we try a few times if there will be an issue with sending. And if we manage, we return true. If not, we return false from this method. Below, you can see the interface of the message. It contains only receiver, sender, and subject, and that's all. So the first question to you guys, and it's worth a mojito drink. What would you test in this send method?
Different response status codes.
Yes, of course. Very good answer. What next?
If we really got the message in the second function,
Yes?
something else.
Can you repeat?
If we really got the message object in this send function,
If we really get it,
if we didn't get something else, for example, it contains
so you mean that,
like
yep.
the sender and the receiver and such would be like empty or couldn't.
Okay, so the idea behind UnitTest is to test if the send method works correctly. So we don't look inside of the method when we test, we just test if it behaved as we expected. So this is the idea behind unit testing. So if someone implemented the send method, we would like to create unit test which will tell us if the send method behaves according to what we expected. So this method, according to what we see, should return true or false based on the response from the server. This is something that for sure we would like to test because this is our contract. We say that send method will return true or false if we manage to send the message. So for sure this is something that we need to test. The other thing that we see, and this is probably some kind of, this might be required by the business logic, that there are a few attempts to send a message. So in case that we didn't manage to send the message for the first time, we will try a few times. This is some kind of retrying. So the next thing that we would like to test would be if actually this method tries a few times to send everything. And usually, when we are calling the method like this, the request.post, this method connects to the real server. So when we execute our unit test, the unit test by definition should not be dependent on anything external. And in this case, if we would call this method from unit test, this method would call the external server and send message to the external server. This is something that we don't want to do in unit test. So this is the third thing that we need to do. In this case, we don't want to send the message to the real server, but we want to make sure that the post method was executed with the correct parameters. So this is the third thing. We need to cut off from sending the message to the real server, but we need to make sure that we will pass the correct parameters to post method. Okay, and there is one more thing. The post method can raise exception in case there will be a failure during the connection. So for example, we deployed this class to our production server, everything is working fine, but suddenly someone took out the cable with the internet and we are sending the message, but the message cannot be delivered to the server. In this case, post method will raise exception about the connection, and this exception will be raised from the send method because we don't catch it, as you can see in the code. So 4 things have to be tested. One thing, what we return from the send method. Second thing, if the exception will be raised. Third thing, if we... What is post method?
Yes.
Yes. So the implementation of post method, this is in some kind of Python library. The name of the library is the request library. Yes, and the post method is responsible for sending HTTP post method to the server. Okay? Okay, so 4 things to be tested.
Sorry, another question?
Yep.
Regarding the exception, you said we we want to test that the exception comes up?
Yes.
And how do we know that it's supposed to? Like, are we testing for it or for that it doesn't come up?
So can you repeat the question?
How do
yeah?
we know if we're supposed to get an exception if we take the cable out?
Yeah. If you would read the documentation for the post method, you would know it. So this question was not simple, at least this one case.
No,
yeah.
I mean for the send method.
For the send method. So with Python, it's not so easy because Python doesn't make us to tell that some kind of method has to raise exception. So it's not easy. You just need to follow all the content of the method to find out this. So it's not very simple. There are other languages that make you to say that explicitly that you need to raise, that it will raise the exception. So you will know it from the definition or from the interface or from something else. So yeah, you can put, for example, a documentation, and this is how you can know it. So, okay. So this is example of basic test that most of you probably will write in your life, or maybe you already did it. This test is based on UnitTest. This is one of a few solutions that are possible with Python. And this is the basic solution. So we create a class. This is a class. This class extends test case. So the tools which are there in Python to execute unit tests will know that this class contains tests. And by default, those tools are supposed to look for methods inside of this class, the methods which start with this prefix. So those tools will know that those methods should be treated as a test method. So anything is inside, it should be a test. Yep. Okay. And the basic structure of the test should be like this, that first we define something that should be given to us. For example, the message sender. The message sender is the class which we want to test, and actually the send method from message sender is something that we want to test. So first we should create the object which we want to test. And this is the object, the message sender class, which I show you on the previous slide. Then we have some additional setup. In this case, we need a message which will be sent with the send method. So this is also a setup. In this case, we have only 2 lines of a setup. Now, we need to execute a method which will be tested. So this is the second stage of our test. And in the end, there is a first stage when we do some kind of assertions. This is the basic of unit testing. Prepare environment, execute the method which is under the test, do some kind of assertions. Is it clear?
For now.
Okay, this is enough. So this is the basic structure of all the tests. So now we go a little deeper. Let's say that creating the message is very complex. We need to call some kind of builders, and it takes a lot of time, and it's not easy. Let's just assume that in this project, it was very complex. Usually, building a message is not a problem, but you can imagine that in your projects, there will be some kind of objects that will be very hard to build. And you will not want to do it in your unit test. For example, because it takes a lot of time, or you don't have all the needed information. Okay, so let's assume that there is some kind of object that we don't want to create as a real object. We just want to create something instead of it, but it should behave like the real object. In this case, I assume that it will be a message. So if we want to fake a message with something that will look like a message, and what is very important, we can easily, this faked object, pass to the method which is under the test. We will use in Python mocks. And what is a mock? As you can see, a mock can be created just like this. So it's just a regular class, and we create an object from this class. But the idea behind the mock is that we can call on a mock anything we want. In this case, we can call an attribute which was never defined on the mock. And mock will always return a value. So in here you can see the result of print method. As you can see, something was returned, although it was never defined. The same is with methods. we can call a method which was never defined on the mock, and it will always also return a value, just like this. This value doesn't make sense. It doesn't make sense for us, but this is how the mock works. So if you need an object which will fake something,
What is value?
value,
Yes.
this is something that is returned by a method. So a method can return true or false, or an integer, or a string.
True or false?
For example, this is a value. So the default value, it doesn't make sense for us. We need to return some concrete value. For example, a message. If we fake a message, we don't want a message to return a subject which looks like ID something and so on. This should be a real subject of a message. So we can do it easily like this. We create a mock object, and next we just assign a value to this attribute. So if we would fake a message, we would say that message.subject is equal to some string. With methods, it's a little different. We just need to use the return value attribute on the name of the method, which we want to fake, and it will return the expected value. We can make it a little cleaner. The code can be a little shorter. We can define those values when we create a mock, just like this, and like, Okay, I cannot show it. Okay, just like this for a method. Okay, how can we work with mocks? The idea when we work with mocks is that this part, the first two lines, we use them in our unit test. So in this given stage, this part, it should be executed in the production code. So usually we don't write it because it's already there. If we created the code which we want to test, so the code in the send method, it's already there. So in here I just put it as an example so you can see what are the stages. And in the end, this is the part which we do in the test. This is the assertion. So this is only one example of the assertions. We can check with this assertion if this method was really called in the code which we test. So let's assume this is in our test, this is in the test, and this is in the send method. If we will call this thing in our send method, with this assertion, we will get information if the method really was called from the send method. So we can easily check what happened in the send method without putting anything in there, anything additional. Based on what I said about the mocks, we could create a mock like this. This would be a mock of our message. And as you can see, receiver, sender, and subject is defined. And this is what documentation says, and usually people will create a mock like this, and they will be happy because all the tests will pass, everything will be fine. But in the end, after a few months of maintenance of the code, adding new features, you will notice that actually this mock doesn't work so good as you would like. And the idea is why. No, the hard-coded values are not a problem.
Maybe we need another mock that would fail. So like if this
Yeah.
mocks returns the true value, we need another one that has like invalid values.
Yeah, of course. It depends on the test. You will need also the test which will check if there was some kind of failure, and you need mocks for that cases also. But still, there will be issue with the mock. So as I said, yeah. Okay, but you mean that send method returns true or false and you are testing this, or you mean something else?
So basically, if you have some object that has like 5 properties or 5 methods,
Yep.
or something like that, and you're using these mocks, this object,
Yep.
in your test, this actually new method. And we test this, it also be true on the new existing method, but actually the test maybe don't include this method.
Yeah, we are close to the answer which I'm expecting. Yes, so it's probably about what you are saying. Yes?
A little difficult should be that you should first define sender, then define receiver and subject. The order of input.
Why?
I know who's going to receive first if you don't send it.
Okay, so yeah, this is other type of discussion, but in this case, it doesn't matter. So the problem is that, as I said, mock will always return something. So this is the problem. It's good sometimes, but sometimes it will be very bad. So let's assume that we created the code, and after many weeks, when everything is fine, all the tests are passing, everything works correctly on the production, and suddenly someone made a change in our message interface. Someone removed the subject, as you can see on the slide. So in this case, unfortunately, our tests will pass. They will not notice any difference, because the mock will always return something. So although a subject was removed from the interface, and maybe someone didn't set the value, still we can call subject on the message, and in the test we will pass here not the real object but the mock. So we can always call something on the mock, and in this case we will call the subject. So if someone made mistake, removed the subject, but didn't update the rest of the code, UnitTest will not protect us. They will not tell us that there is a failure. And this is one of the things that UnitTest should give us. They should tell us that you made a change and you broken some other part of the code. UnitTest should protect us from this. And with mocks like this, unfortunately, they will not protect us. So this is the trick, the hack, or the issue which I wanted to tell you about during this presentation, that yeah, on production, dragons will come, because we tested everything, test pass, okay, let's go for production, and then, wow, our clients are not happy because they say that there are some failures and we didn't get it in our tests. So the solution is to use the SpecSet attribute. This attribute will tell to the mock that there is interface defined in the message class, and anything that happens with the mock should be according to this interface. So we cannot call things that are not defined in the message class, and we cannot set in the mock things that are not available. I say things because it's not only variables. It can be also methods. Yeah. So the SpecSet attribute will protect us. It will check the interface, and it will not allow us to do things that doesn't exist in the real class. Okay, so yeah, another question. What if the message interface would be implemented like this, so that the attributes, the fields are not defined on the class, but are defined in the init method? Will using the SpecSet also protect us? Please.
You cannot see inside the method in this case, so you must use some reflection or something.
Exactly. Exactly, this is the problem, that if those attributes are defined only in the init method, not on the class, then the SpecSet attribute will not protect us when creating a mock. Mock will not notice those three attributes. And this is a real life issue, because, for example, the response status code, this attribute, is defined exactly in this way. It's not defined on the class. If you will go deep into the code of this library, you will see that status code is defined like this. So we cannot mock it with the SpecSet, because the SpecSet will fail and will tell us, no, you cannot mock this response object if you will want to do this. So in this case, we need to use the spec attribute. It's not so good as SpecSet, but it's enough in this case. It will protect us from calling things that are not defined in the response, and it will also allow us to set in the mock values which are not defined in the class. So we can create this mock, and we can call status code also, although it's not defined on the class. Okay, we know how to create our mocks for the message. In this, at least in this example, in your projects, it will be much more complex situations to create a mock. We know how to mock the response because, as I said, we will not send real messages to the real server from our unit test. So we just need to mock this response so we can test different situations in this case. So how now we can make our post method to return different responses, because we don't want to use the real implementation. If we will use real implementation from our unit test, it will send everything to the real server. We don't want to do this. Also, we don't want to change this code on the in the production code, because yeah, this is how it works on production. So why do we want to change it for the unit testing? So the answer is, sorry? Yeah, we need to use a patch, because as you can see, actually, okay, we will. Yeah, you mentioned this, but first I wanted to show you something, something better, something much better. We should change the implementation of the class, and this is something that you should always try to do first instead of going with the patches. So as you can see, this is only a part of the code, but this is based on the code from the previous slide. Instead of calling request post, we should make some variable on our class and call post from this variable. And this variable should be set by injecting from the init. So whenever someone creates message sender, this person is responsible also for setting the correct object that will be used for sending the messages. And this will allow us to not go for the patching. But let's say that for some reason we cannot change the code. This is what I suggest. This is the best solution because it will save us from using the patches. But if it's not possible, and let's say in our case it's not possible, then we need to go with patches. So we use patch when we cannot pass easily a mock. This is when we use a patch. And usage of the patch is very simple. This is the test method, which I show you at the beginning of the presentation. We just use the annotation patch. We say what we want to fake. This fake is passed to our method, test method. We assign the value which we want to return from this fake, and then we do some kind of assertions. In this case, we make assertion if the correct parameters were passed to the method, because that's all what we can do, instead of sending everything to the real server. Okay, the difference is in here. Instead of using patch and defining a string what we want to fake, we use patch object, and this allows us to use a real import. So instead of using strings, we have real imports, and the benefit is that when you will create a lot of code, and in a few weeks from now, when you have a lot of code created, you decided that we will switch the paths, we will move some code from one file to the other file, or we will just rename the directories, and then it occurs that the imports will change. There will be a total refactoring. So IDE can support you with doing the refactoring of the paths of the directories of the files, but if you will have patches defined like this, IDE will not see it. It will not go there, and it will not fix it for you if there will be changes in the paths. With this solution, IDE will notice it, and will support you and will fix it for you. So this is another thing that I suggest you to use. Okay, and this is another hard thing about patches, so that's why I suggest to not use patches. If you want to use them, make sure that you really need to use them. It is very important when you use a patch to tell that you want to patch something from the place where you are using it. So this post method is used from request library. And this is how you will create a patch for it. But in this case, we are using the same post method from the same library, but the difference is that we are not using it from request.post, but we are using it directly, like post. So for patch, it means that this method is used from this module and not from requests. So in this case, if we want to make a patch for the post method, we need to say that we are creating a patch for a post method from the name of this module. I assume this module is called message sender. And some people are doing it like this, but I think it's not the best idea, because if you will have a lot of different classes which uses the post method, then when you create tests with patches for those different classes, you will always need to switch this part. So each time you create a test, you need to think what to put in here. If you will go with this solution, you will always create a patch like this. So it's much simpler. Okay, so we know how to fake this part. We already know how to pass the fake message and how to fake the response. So now we can think about what we said at the beginning. So one of the things was that we would like to not send the real message. We already know it because we are faking this method. The other thing was that this method in real life can raise exception, and we need to check what happens with our code. In this case, our code just rises it further. So we would like to make this fake to raise exception so we can test what happens with the whole code. And with patches, it can be done easily by using the side effect. We just say that our mock, our fake of the post method, dot side effect, and we assign the exception to it. So this is very simple. And another suggestion from me is that you should always add some kind of message to exceptions which will rise from your unit test. The message which will tell you that this exception was expected to be raised from unit test. Because you will notice that if you will execute a lot of unit tests from the code which you don't know, and you will see the logs from those unit tests, and there will be some kind of exceptions in those logs, then you will think that, I don't know, maybe I broke it, maybe my change did it, but on the other hand, I didn't change anything, so why are there any kind of exceptions? And if you will see messages like this, that expected exception from unit test or something like this, then you will know that, okay, this exception was meant to be raised. These are unit tests, I executed them. This message is in those logs, so it's fine. I didn't break it, it was expected. So also side effect can be used for different situations. For example, we said that, let's go back for a moment. We said that there are a few attempts done just to send this message in case the status code is not as we expected. So we can call this method a few times to get what we wanted. And side effect can be used, in this case, to return different values. So if instead of this exception, we will assign a list of many values, then this list will work in the way that first object is returned when we call post method for the first time, second object is for the second call, third for the third call, and so on. So side effect can be used for many different situations, and you can find more in the documentation. So now, usually developers work in the way that they go for the conferences, for the meetups, they listen about fancy technologies and different stuff, and after going back to their projects, they decide that, wow, this was great, so now I will do it. I don't care if it makes sense in my project, for sure it makes sense, I will do it. So yeah, in the end, some of you may end up with a test like this, when we have 4 patches, for example, or even more. I saw more, 5 or 6. I think this was the most what I saw. And you might think that it's really good, and it might even work for a week or 2, but then you will need to maintain this test, and you will notice that it's not maintainable. It's a huge pain, and it doesn't work. So I saw it, I checked how it works, and from my experience, if you see something like this, it means that you don't want to use unit tests in this case. In this case, you need to use integration tests. Because if you need to patch so many things, it means that your class is integrating different stuff. And when it's integrating, it doesn't make sense to create a unit test. You need to create an integration test. So 3 things that I would like you to remember after this presentation if you are going to develop with Python and you would like to do it correctly and top level. Then first of all, maybe it's not on the list, but first of all, do the testing. Do your testing, develop your test. Unit test, integration test, whatever you want, whatever you need actually. And from the presentation, of course, if you are doing unit tests, then if you can easily pass the fake object to the method under the test, please use the mocks. If you cannot do this, think if you can change your code and do this. In the end, use patches and don't over-engineer it. Okay, any questions?
What happens if the code stops using request.host but something completely different?
Can you say some example?
Like I'm starting using URL not request.host and I write it in the code. Now the unit test should warn me about it.
Okay, you switch from one implementation to the other. You just change the library. This is what you are asking?
Yeah, and the mock was for request.host, right? So it will actually execute the real thing in the test, which is not the desired thing.
Okay, so what you asked about is a great example. Why should we implement this sender like this? Because with this implementation, it doesn't make any difference which implementation of the sender we will use, if it will be a request library or the other library. So what you said is a great example why this implementation is the best. You can just inject different libraries for sending and it will always work. And to answer your question, there was a very nice sentence about unit tests. Unit tests are not to protect us from failures now, from the bugs. They are to protect us from the changes which will happen in future. So exactly what you said. If you will change something in the code, the test should fail and show you what exactly is broken, and then you can fix the broken part. So it should fail, and it should tell you what to fix. I still have a few mojitos to give. Yep.
How come when you do in the requests, you said that one of the things was initialized in the init, self dot something?
Yes.
I don't remember what, maybe the response code.
Yes, it was response. Yes.
Can we make it so that mock will know what's initialized with self dot in init?
No, you can use only the SpecAttribute, but you cannot make mock to know about it.
Is it possible without mock or something else?
I don't know any other libraries. Mock is the most used, the most common. Yeah.
Could you actually instantiate the message and use the instance as the pattern, how's it called?
Interface?
The reference. Yeah, the template. So in this example, you're using the class as the
Yes.
template.
Yes.
But could you instant it so that the init method actually executes and populates the desired fields?
Yeah, but wasn't the point of the whole exercise to not make an object because it's hard to
Yes. Yes, exactly. So yeah, maybe this is a very simple example. So it doesn't make sense to create a mock instead of a message. You can just simply create a message, and this is what I would do in this case because it's just too simple. But there are cases when creating the object is very hard. And for example, when you create an object, you need to read something from a file, and you just don't want to do this for some reason, or you need to get information from internet, something else. So you can imagine these cases when you just don't want to use a real object.
function to validate emails.
Yep.
And how would you approach that? I don't know, let's say you have 5 emails,
Yeah.
which like edge cases.
Yeah.
And you want to test them all. That 4 of them are okay and 1 is not. How would you approach this? Like hard code them or what?
And what do you mean that 4 are okay, 50 is not okay? What do you mean?
4 are validated,
Yeah.
and are real email, and the 5th one is not. So how would you approach and test all those 5 emails and make sure that you get always the same response? And let's say it's not just true and false, it actually gives you a reason why this is not an email.
And what kind of validation do you mean in this
Let's
case?
say if we go simple, is that email or not? So if it has like dots inside
Okay.
and stuff, for example.
Okay, so in UnitTest library, there's actually it wasn't in the library. There was an extension which allows you to parameterize the unit test. So you can just create one unit test which checks the validation of the email, one particular email, but then with annotation with this library parameterize. I don't remember the correct name. You use it with annotation to the test. You can just define different values for the email and different responses that you expect.
Yeah, the match is okay, yeah.
Exactly. And it was a few years ago when I used it, because later I switched to PyTest and it has other plugins. So I'm not sure how it works with UnitTest, but with PyTest you have similar solution. In other languages,
How common is this type of test? Because actually hard coding the value and hard coding the response. Is that like common or not?
yes, so there are two paths to solve it. One path says that don't hard code it because the test will be more, you will not need to change the test when the values will change. The values will be dynamic. So just create an object and compare.
If you have edge cases, you can
Exactly.
anything else and just calculate it.
So yeah, this is the issue with the dynamic values, that you will not know what actually is tested there and the edge cases. So the other solution is just to hard code the values, and you just need to check what is better for you in particular scenario. So yeah, there's no good answer in my opinion in this situation.
So I have a question. So I wonder sometimes that some languages, I don't know about Python, but some languages support multiple assertions per function. So
Yeah.
I wonder sometimes if this is good practice or
It's not
not.
fast to use more.
Actually, it depends how they will tell you that there was a failure. If they will tell you that the failure was in particular case and you know what were the parameters passed there, then it's okay. It's just like parameterizing a test. I think it's okay. Sometimes I saw that people didn't know this annotation solution and they just created one test and inside they executed a for loop and there were assertions inside, and when there was a failure, they didn't know which parameter, which iteration of the loop was the failing one. So they know something failed, but they didn't know what, and this wasn't the best solution. So in this case, what you said, I think it's okay as long as you have the full path, the full root cause of the failure.
Yeah, because in some assertions you can also return some string that should
Yep.
tell you something. So it could actually be told, could actually be told what is wrong, also with multiple assertions. But
Yeah.
I assume
Okay.
that maybe it's something practice because you have to decouple the functionality into small pieces, maybe.
As long as the test is clear and you can read it fast and understand what it does, it's okay. If the test is complicated, then you just need to split it. I saw so many complicated tests that I just couldn't understand what it does and why it fails or not. So as long as it's simple, it's okay. Okay, any questions? Okay.